Okay. I don't think we'll have Adnan today. I don't know now. You see, this is the thing. Every time he comes when he's late. In other words, he's usually here by 9:15, or he's not here. You know this for a fact. We shall see. And Mir could be as late as 10 o'clock. All right, let's open up the next worksheet. Maths part 2. Maths for engineering. Okie dokie. This is what we did last time. Yes, this is what we have today. Okay, so what we're going to learn today is really how can we use some of the rules that we have from trigonometry to help us do some integration problems. So the first one I'll have a look at, I'll do one from each as an example. So the first one is 4 integrate cos squared 2x. Come in. Now you see, I said you wouldn't be here, and Iyad said you would. Because I was saying, Adnan, when he does come, it's never this late. I guess I was wrong. You pushed it too far for attendance for 9 o'clock class. Why? It's 9:18.
What?
You are too late for attendance for your first class. Yeah, seriously. Now it's 9:19.
Please.
Please what? Please, teacher, I'm sorry I'm 18 minutes late. Forgive me. Why are you so late? Give me a good reason.
A good reason?
I rest my case. Do you have to save any kittens on your way to class?
A dog.
A dog, puppies, great, okay. Right, so for this problem here, one way we can solve it is by changing this into cos 2x, cos 2x, and then we think about our cos and sine compound angle formulas. So for example, you know that cos A plus B and cos A minus B, it will be equal to cos A cos B minus sine A sine B. You remember this one? And then you have cos A minus B is cos A cos B plus sine A sine B. If I add these together, I'll get cos 4x plus 1, because this is cos 0. And this is equal to 2 cos 2x cos 2x. So in other words, cos squared 2x. If I just look at this 4 and just put it inside for the moment, I nearly have what's in the question. I have 2 cos squared 2x, and I need 4 cos squared 2x. So what should I do here? I should multiply by 2. So if I put a 2 here and a 2 here, this one becomes a 4. And now what I have here is exactly what's in the question. So I can now say my original problem, instead of being this, is equal to integrate 2 cos 4x plus 2 dx, which is much easier to do because this was requiring the integration by parts formula because it's a product. But now I don't need any special formula, I just integrate regularly. So cos becomes sine, and we divide by 4, and 2 becomes 2x plus c. So what I did here was I used compound angle formula instead of using integration by parts formula. In other words, I simplified the integration into something which is not really special. There's nothing special about this integration here. But there is something quite difficult about this one. So this one would have been quite hard to do, whereas this one is easy to do. And the trick was to use the compound angle formulas. Okay, so this is our first example of using trigonometry rules to help simplify trigonometry integration. I'll do a couple more, if you can write this down, please. Got that? Continue. With another example. Not of this, but a different type. Yeah. Which we've. Yeah. Okay. So that was using compound angles to help simplify a problem. So the next one, I might do 2 examples here. But before we started, I have to give you a formula, which I think I did, but I'm not 100% sure, so I'll do it again. We have y equals sine inverse x. If I take sine of both sides, I get sine y equals x, or in other words, x equals sine y. Let's just draw a little triangle here. So x is the ratio here. No, sorry, I got that. Sine of an angle, sorry. So it's y is the angle, x is the ratio. So that's x. But you know, sine is opposite over hypotenuse. Sine is opposite over hypotenuse. So that's 1 there. And this will have to be root 1 minus x squared. Differentiating, but it's just backwards. The x is like the y and the y is like the x. So this will be dx dy equals cos y. But cos y is root 1 minus x squared over 1, because that's what cos of y is, adjacent over hypotenuse. That's the derivative of sine. If I flip this upside down, I get dy dx equals 1 over root 1 minus x squared. So in other words, the derivative of sine inverse x is equal to, I think this is sine inverse.
No, I mean 1 over. That's 1 over 1 plus this. Is that sine inverse?
That is
Or 1 over
cos, yeah, because it's adjacent over hypotenuse.
This is hypotenuse over
Ah, yeah. So what I did from here to here is I flipped both sides upside down.
Yeah. So what does that make?
Oh, what would this be?
Yeah.
True. It's hypotenuse over. It's what you call it? Sec y. Yeah. If you want to know what this one would have been, it would have been secant y. Okay, so we have the derivative of sine inverse x is equal to secant y. So that means sine inverse x is equal to the integration of 1 over root 1 minus x squared dx. And of course there's a plus c here. So I just wanted to do this little proof for you. Now, I told you that trigonometry proofs are on the exam. That is true. And in fact, this is a trigonometry proof. It is on the exam, and it has been on the exam at least once recently, possibly twice. So they could ask you to prove this for the exam. Exam proof. And interestingly, everybody who did prove this in the exam proved it a completely different way.
How?
Well, that's what I'm going to let you think about. You got this, Missionary? Yeah. Adnan? Yep, I can go to an example now. So let's have a look at an example. Yeah, we'll go with just the first one as an example. 1 over root 16 minus x squared dx. So we've done stuff like this. I wonder if anyone remembers what substitution was useful here for this one. We did it with, I think, tan inverse, maybe. Yes, it was with tan inverse in the integration 2 chapter. Maybe it'll look familiar when I do it. It's square root x squared over 16 So u equals x over 4, so u equals a quarter x. So that means, over here I can say du dx equals a quarter, so 4 du equals dx. So I have this, which will be useful. Also I have, where's it gone? I need x here. X equals 4u. That would be useful as well. Putting both of these back in here, this becomes 1 over 16 minus 4u squared, and dx becomes 4 du. So this is 1 over root 16 minus 16u squared over 4u, which is 4 du over root 16 root 1 minus u squared, because I can take the 16 out here. But root 16 is 4, and 4 cancels 4. So you're left with du over root 1 minus u squared, which is perfect because you have a rule for that. It's sine inverse u, and we know what the u is. So that's sine inverse x over 4 plus c, and that's the answer. Typical exam question, section A or something. The trick was this substitution, was the trick here. Okay, so if you can write that one down. Continue. Yeah. Yep. Yep. Okay. Let's have a look here. I want to give you one like this to try, but a little bit harder. I want to see if you can figure out the extra step. So I'm going to do let's pick one with smaller numbers, might help, like I. So I'm going to do I. It's very similar to what I did, except if you look at it, there's one big difference between I and G, or sorry, I and A. what is extra in I that's not in A? The 18x, yeah. But it's still done the same way. You're just going to need to do something about the 18x. So I'll let you try to figure it out. I'll give you a minute or two. I'm going to do it now, in a moment. Do you think you figured out the way to deal with it? You did, you're good. Finish, Sherry? Sleepy?
Yeah.
Ian, what was your trick, or did you think of a trick? No. Sherry, did you think of a trick? Yes, that's the one. Let's have a look. So, next example. Is Adnan asleep? No, you're awake. It's just you're so calm and relaxed. Some people might think you're asleep. Not me though. I knew you wouldn't do that to me. Right. Integrate 1 over root minus 65 plus 18x minus x squared dx. Right, let's do a little bit of simplifying here on the side. So we know that minus 65 plus 18x minus x squared can be written as minus, bracket, x squared minus 18x plus 65, which is equal to minus, bracket, x minus 9 squared, and then, let me see, that's 81, but I need 65, so I think I need to subtract 16 here. Okay, and if I put the minus back in, that would be minus x minus 9 squared plus 16, which is 16 minus x minus 9 squared. So I can rewrite this as integrate 1 over root 16 minus before. I can say u is equal to root, come on, root we'll get there. There we go. Root x minus 9 squared over 16. So u equals x minus 9 over 16. So u equals 1/16 x minus 9 over 16. So that means du dx equals 1 over 16. So 16 du equals dx. So that will be useful on the top. I can change that to 16 du. And then on the bottom, x minus 9, if I just take this here and bring the 16 up, I would get 16u equals x minus 9 from this line here. So that's useful because then I can change this into, oh sorry, writing mistake here. Square root 16. So that's 16 there, they should be 4, so I'll fix them in blue. So that's a 4, 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 and that's a 4. Okay, as I was saying, 16 minus x minus 9 squared, x minus 9 is 4u. So if I square that, that'll be 16u squared. Same thing happens, I can take the 16 out, but root 16 is 4. So just like in the last example, they'll end up cancelling with the 4 on the top. So I'll just be left with root du over root 1 minus u squared. Again, just like the last example. Yep.
How is minus 16u squared?
How is it? Because it's 4u squared. X minus 9 squared. 4u squared. Yeah. That will be sine inverse u, which will be sine inverse x minus 9 over 4 plus c. That's the answer.
When you take the square root x minus square minus the constant.
No, the square root and the square cancel. You have this written down. Yeah. Yeah? Okay. Let's have a look at the next one. Right, so the next one is going to be, we'll do this one here. Integrate root 16 minus x squared dx. Okay? So, this kind of looks like the last one I just did, except for one big difference. It's not a fraction. In the previous example, it's 1 over root 16 minus x squared. You might think, that makes it easier. In fact, it makes it harder. That's why it's the last one. So, we start off by just drawing a triangle here. If I remember correctly, what you do is you call this side x and this side 1. So what's this side? Root 1 minus x squared. So actually, I'm going to call this side 4, and this will be root 16 minus x squared, and I'll call the angle here u. So this triangle is a way to help us pick the best substitution. In fact, the best substitution here, we can say is cos u equals root 16 minus x squared over 4. So 4 cos u equals root 16 minus x squared. And this is the substitution I would use. And the reason I drew the triangle is to help you make this, because it's too difficult to try and make it by itself. We need to draw a triangle. So the way it works is you place this side you call it x because this is x, and this side you call it 4 because this is 4 squared. So if you want, you can think about it like this: 4 squared, and we get that. So let's see what happens. Well, that's nice because that changes into 4 cos u, and this one this is still dx. So okay, it's good that this is simplified, but we still have to do something about the dx because we need it to be a du, not a dx, which is kind of a problem. So you might think, oh, okay, so I'll use this to simplify it, but this is kind of messy to get the du and dx from this, because I mean, you're going to have to differentiate a root. You know, root's going to be messy. What you could do instead is look at sine u, because sine u is only x over 4. opposite over hypotenuse. So you can get the du dx from that instead. So if we differentiate, if I bring the 4 up, 4 sine u equals dx, and differentiate, this will be dx du, because it's like the x is like the y, and the u is like the x, they're the other way around. This becomes 4 cos u. So you end up with 4 cos u du equals dx. So what you can do is you can change this into 4 cos u, and then your dx, you can replace it with 4 cos u du, which will be integrate 16, the 4's, I just put them together, cos squared u du. And you've seen this problem before. In fact, it was the very first example I did today. Nearly the very first example. My very first example was 4 cos squared 2x. So my point is, you can just do what we did in question 1. We can say cos u plus u equals cos u minus sine u, and then cos u minus u is the same thing except with a plus, and then just like in question 1 we add them together, so this becomes cos 2u plus 1. Now I just realised, did I make a sign mistake in my first example? No, I didn't. Okay, and then here we get 2 cos squared u, and we're nearly there because we need 16 and we have a 2, so no problem, we'll just multiply both sides by 8. So this becomes 8, this becomes 8, and this becomes 16. And now what you have here is exactly what is here. So this now becomes integrate 8 cos 2u plus 8 du, which becomes 8 sine 2u over 2 plus 8u plus c, but I'll put the c in at the end. So you might think, great, I've integrated, I've finished, but there's a small problem with my answer. What's that? What's the small problem with my answer? Well, I guess it's not that small a problem, it's a pretty big problem with my answer. Nah, that'd be a small problem. Big problem. No, that's a small problem. Yeah, okay, so I could change that into 4 sine 2u plus 8u, but still there's a pretty big problem with this. Huh? Yeah. The u. It should be in x, not in u. Because we started off with x, we should finish with x. So what I'll do, I'll change this into 4, and then we have the double angle rule for sine 2u. If you remember, that's 2 sine u cos u plus 8u. That will be 8 sine u cos u plus 8u. And you might think, well, that hasn't simplified it much, but it has actually, because we know what sine u and cos u are. We have them from this triangle. Sine u is x over 4. Cos u is root 16 minus x squared over 4. So I can change this into 8 x over 4 root 16 minus x squared over 4 plus 8u. So what's left to replace here in the last one? The 8u, yeah. So I think I'll get the u from this one. I could say u equals sine inverse x over 4. 4 times 4 is 16, 8 over 16 is a half. So this is equal to a half x root 16 minus x squared plus 8 sine inverse x over 4. Can I squeeze it in? Plus c. And that's the answer. So I told you it was harder, and I wasn't joking. Yeah. Yeah. Okay. Now there's let's see. There's one more example to do, but what I think I'll do is I'll give you a 5-minute break. Then when you come back, we'll do the other example, and then I'll let you work on these for a little bit. I think this is the last section in trigonometry, isn't it? Let me just have a check, and then I think we're on to statistics. We're on to vectors, which we did, of course. So then we must be on to statistics. Yeah, on to statistics. Just remind me, tomorrow we have a double class, yes? And Wednesday? When's our last double class? Okay. So this is when I'll give you the maths revision test.
Oh,
Wednesday.
right.
The last double class. Yes? Now, like I said, you don't have to give me the test up afterwards.
Looks semester 2.
All of everything.
What?
Everything up until then.
Even semester 1?
A little bit, but I mean,
It is kind of, we need to know it. We're supposed to do something.
I know, but you should know it. Do you know what I mean? Like, it shouldn't be that all this time you didn't know anything about semester 1, and then like, oh, I have to know that. You know, because the exam is in a few weeks on everything. I mean, I can give you just semester 2, but I'm trying to, and like I said, I don't care about the results, because you can keep the test afterwards and never show me it. Do you know what I mean? I just want to give you a chance to see what you need to be doing. So if you want, I'll give you the test with semester 1 and 2 in it, and if you only want to do the semester 2 questions and only want to be marked for that, that's fine. If you only want to do semester 1, that's fine too. And if you want to do both, that's fine too. It's your choice. This isn't for me, this is for you. I'm not doing it to get results off you, because like I said, you can take the test home afterwards and I can never see it if you want. Or you can give it to me to be corrected if you want. Your call. Fair enough or not? Fair enough? So that will be on Wednesday then. Yeah. And again, you can use your notes or not. It's entirely up to you. I want you to use this as a revision opportunity. Do you get what I'm saying? Yeah? Okay, take a 5-minute break and then we'll continue with the more difficult or even more difficult example when you come back.